So a company produces hockey pucks. League regulations state that the weight of the puck has to be between 164 and 170 grams. So we have a production equipment that's set to produce pucks that have a mean mass of 167 grams, and the standard deviation has been calculated to be 1.1. Alright, so we have to do some quality control testing to make sure that these pucks fall within that range. And to ensure that only a small number of pucks are rejected, the quality control manager must ensure that the mean mass of pucks lies between the range 166.7 grams to 167.3. During each workday, a random sample of pucks is selected and weighed. So here we go, we've got some confidence levels versus sample sizes. You'll notice the more pucks you are able to sample, the better the confidence level. So for example, 36 pucks gives you a 90% confidence level, and 89 pucks gives you 99% confidence level. Determining these confidence levels mathematically is not within this course, so you don't need to worry about that. Typically they might give you a table, if anything. So the question is state the confidence interval the company is using for its quality control tests. Okay, so in this case, that's going to be the interval. It's going to be 166.7 grams to 167.3 grams. So the question is, state the margin of error the company is using for its quality control test. Well, this is the interval. You can use this to figure out the margin of error. What you're going to do is take your larger number, so that's 167.3, and you're going to subtract your lower number, which is 166.7. What you're going to find is 0.6 difference between the two. If you divide that by 2, that's what you're going to get for your margin of error, and that's going to be plus or minus 0.3. That plus or minus is important, don't forget it. So the question is, how many pucks should be weighed in each sample if the company wants to ensure that the mean mass is in the range 166.7 grams to 167.3 grams, 49 times out of 50? Well, you're going to use this right here. Take 49 and divide by 50 and times that result by 100. You're going to find it's going to be a 98% confidence level. In that case, look it up on your table. What we're going to need is 73 pucks. Pucks which do not satisfy the league regulations can be used in practice. How many pucks should be weighed if the company wants to ensure that the mean mass is in the range 166.7 grams to 167.3 grams, 9 times out of 10? Same thing, you're going to divide 9 by 10 and times it by 100. What you're going to find is you want a 90% confidence level. In order to achieve that, you need 36 pucks according to that table. And in E, if the company were willing to accept a mean mass in this particular range, would they need to test more or less pucks than in the table to attain the same confidence level? Well, if you notice, this range is slightly bigger than the one that we were dealing with before. In that case, if you're willing to accept a wider range, you need fewer pucks. The smaller the range, the more you're going to need to test a lot in order to make sure that your mean is within that range. But if you're willing to accept a wider range, then you're okay with using fewer pucks to make sure.